on gut microbiota modification. My name is Hania Szajewska. I'm professor and chair of the Department of Pediatrics at the Medical University of Warsaw, Poland. My scientific card belongs to ESPGHAN, European Society for Pediatric Gastroenterology, Hepatology and Nutrition, to ISAPP, International Scientific Association for Probiotics and Prebiotics, and also to evidence-based medicine. Let me start with this quote: "It's better to be rich and healthy than poor and sick." And it also applies not only to life, but also to microbiota. It's better to have a rich and diverse microbiota and be healthier than poor microbiota and be sick. And this is because if you look at the features of normal gut microbiota, I mean normal, which is health associated, you see that this richness, diversity is important. Increased species richness, increased diversity, high gut microbial gene richness, and resistance, resilience, and stability over time. These are the features of normal gut microbiota, even if there's no consensus into the detail, but this is generally what is considered. So diversity matters. On the other hand, there may be the dysbiosis, and again, there is no consensus what does dysbiosis means, but usually this is a change, imbalance, so there are changes, alterations in the gut microbiota composition, but also in the function. And by now we know that almost every disease, when you talk about the pathophysiology, then dysbiosis is being contributing, hardly ever as a single factor, but definitely contributing to the pathogenesis. We also know that gut microbiota changes across the lifespan. And this slide shows you the evolution in terms of richness, which is so important, and diversity, starting from pregnancy and prenatal life. Of course, a lot is happening from birth to 2 years. Then it's more or less stable during adulthood and the elderly. Again, there is reduced diversity with all its consequences. There are many factors influencing, shaping the gut microbiota, again, throughout the life. I will not discuss all of them. I just want to focus on one of them. And these are antibiotics. Definitely one of the biggest discoveries, greatest discoveries of in medicine, saves lives. However, we do have problems, and this is overprescription of antibiotics. In the United States, approximately 25% of hospitalized children get antibiotics that they don't need. And these are very recent data from 2020. Other data, just as an example, from New Zealand, recent study, 2020, at least one course dispensed to more than 82% of children during the first 2 years of life. So we do have a problem, and with overprescription of antibiotics. There were just 2 examples. Another example, 33 to 39% of women are administered antibiotics during delivery. And it's not without the consequences, because if you look at the gut microbiota, then you will see this reduced abundance, mainly of fecal bifidobacteria during the first weeks and months of life, with the consequences on the number of diseases. And as a matter of fact, together with my colleagues from my department, from our colleagues from the Netherlands, we look at early life antibiotic exposure. And by that, I mean early life, I mean during pregnancy and during the first 2 years of life, and risk of diseases. We now published all this, there are 4 papers based on these various systematic reviews. And what is documented are the association between prenatal antibiotic exposure and infant antibiotic administration and childhood allergies, but also overweight and obesity. We did not find it for other conditions, but others, and this is a very recent paper from the United States, more than 14,000 children, of whom 70% again received at least one antibiotic prescription during the first 2 years of life. And you will see that there are associations of this early antibiotic exposure with a number of outcomes, such as asthma, allergic, atopic dermatitis. So again, what more or less I showed you previously. So we do have a problem. And other factors, there's a number of other factors, but I would not discuss it in details. And antibiotics are not the only drugs that affect the gut microbiota. Many others, and when we are speaking about pediatrics, it's definitely in the proton pump inhibitors, the use of which, overuse, may be problematic. And as I said, there is a number of other factors which contribute to the changes of the microbiota. But as one of our colleagues said, the patient does not care about your science. What he wants to know is, can you cure him? And this brings me to the strategies to modulate gut microbiota with various biotics, such as probiotics, prebiotics, synbiotics, and postbiotics. And let me briefly discuss them. A number of those were already covered by ISAPP, International Scientific Association for Probiotics and Prebiotics, when it comes to definitions and also the appropriate use of those terms. So I will just briefly try to focus on some of the pediatric issues, starting with probiotics, which are defined as live microorganisms that, when administered in adequate amounts, confer a health benefit on the host. As I have another presentation on probiotics only, I will not cover it now, and I will move to prebiotics. Again, this is a definition which was provided by ISAPP, and the probiotics are defined. A probiotic is a substrate that is selectively utilized by host microorganism, conferring a health benefit. And there is a number of health outcomes, health endpoints targeted through human trials of orally administered probiotics for obesity, for satiety, some of the studies, for allergies, for IBD, IBS, constipation, so a number of those. Of course, not all prebiotics are equal, so each one of them has to be evaluated separately. I just want to focus very briefly on infant formula supplemented with prebiotics. I will very briefly touch HMOs because it will be covered in the next presentation by Professor Ivan van den Plas. When it comes to infant formula supplemented with prebiotics, together with my colleagues, a few years ago, we published this systematic review that we looked at the outcomes, what are the effects of supplementation of infant formula with prebiotics. And what was really well documented, I'm not showing it here, is that all studies, and there are more than 40 studies that were included in our analysis, all of those studies show that it has an effect on stool microbiota that increases bifidobacteria, but also had a number of positive clinical outcomes. And I just want to show you, in the context of I discuss the overuse of antibiotics, that the use of at least some of this prebiotic supplemented formula contributes to decreased use of antibiotics. Extremely important outcome, not evaluated in all of the trials, unfortunately, but important in the context of these changes in the microbiota. Human milk oligosaccharides, progress in biotechnology nowadays allows to produce at least some HMOs to be added to infant formula. So they are some mainly with 2FL and LLNT, and Professor Ivan van den Plas will cover it. So I will just show you one example, again, in the context of the discussions that we had on the use of antibiotics, that at least one of those studies showed that adding 2FL, 2-fucosylactose, and LLNT, lacto and neotetraols to infant formula reduced parent-reported morbidity and medication use, and particularly they reduced the use of antibiotics by 31%. I think this is an important outcome to be evaluated further, again, in the context of the discussion on the effects of antibiotics on microbiota. Now let me move to another biotic, which are synbiotics, and again, what is new in 2020. This is a consensus paper published very recently by ISAPP, looking at the definition, updating the definition and scope of synbiotics. And as you can see on these slides, synbiotics are defined as a mixture comprising live microorganisms and substrates selectively utilized by host microorganisms that confers a health benefit on the host. And what is important that symbiotics may be formulating using two approaches, complementary symbiotic and synergistic symbiotic. Complementary means that there is a mixture of probiotics and prebiotics, and each works independently to achieve one or more health benefits. And synergistic symbiotic is a mixture of selectively utilized substrate and the live microbes chosen for its ability to deliver a health effects. And of course, the combination has to be shown to be documented that the specific combination will have an effect. So two different approaches to symbiotics. Again, there's a number of studies looking at symbiotics. I just want to show you one of those, that a symbiotic may help prevent neonatal sepsis. Huge trial, more than 4,500 participants performed in India, where the death because of the sepsis is really a problem. And they included infants at least 2,000 grams at birth. And this is a combination which was used compared with placebo. Sorry, intervention was for 2 weeks. And the primary outcome was composite of sepsis and death. And here you see reduction in the risk of by 40%. So it shows you really that there is a potential when it comes a proper use of the use of a proper symbiotics. And of course, there are some other studies on symbiotics as well, but for me, this is one of the most important. And finally, let me move to postbiotics and very briefly, what is pending. First, what is already known on this term. So the term postbiotics is increasingly found in the scientific literature and on commercial products. However, the term is inconsistently used and lacks a clear definition. And as a matter of fact, if you look at the literature, you will see there are several different terms, all defined differently, that have been used over the years to refer to some form of inactivated or killed microbes. Paraprobiotics, parapsychobiotics, ghost probiotics, metabiotics, tendalized probiotics, bacteriolysates, and many, many others. And there's a confusion and there is a misuse. So what is needed, I think that everyone agrees that consensus over the definition of postbiotics is needed, and the field would benefit from a single, well-defined and understood term rather than use of different terms for similar concepts. And as a matter of fact, it's important for scientists, for regulators, industry, for media, for consumers, so for everyone. And as a matter of fact, ISAPP, International Scientific Association for Probiotics and Prebiotics, has finalized the work on, almost finalized the work. It's still waiting to be published, but this is a proposed ISAPP definition of postbiotics. And the postbiotics is a preparation of inanimate microorganisms and or the components that confers a health benefit on the target host. And as always, every word is important. So it has to be inanimate microorganisms. These components, the health benefits are important. As always, in every definition, the health benefit has to be documented. There are many potential postbiotics and possible activity linked to this potential health benefit. Just some examples. So heat-killed bacteria, they may contribute to immunomodulation. Short-chain fatty acid may have anti-inflammatory effects, enzymes and bacteriocides with antimicrobial activity, and gamma-aminobutyric acid, which is a mood regulator. So potential postbiotics and their effects. Many others, of course, they are also available. What are the postulated mechanisms of postbiotics? There's a huge question mark. We still don't know. A lot of more studies are needed, but what has been summarized, and it was also summarized in this document that ISAPP will hopefully publish very soon, the beneficial modulation of the activity and composition of the resident microbiota. There are studies on the enhancement of epithelial barrier functions, modulation of the local and systemic immune responses, modulation of systemic metabolic responses, systemic signaling via the nervous system. So some of these postulated mechanisms. Examples of postbiotic use, there are examples both in adults and in children. Here is a summary of some conditions, clinical trials with when this whole concept of postbiotics was tested or was studied. And one of very recent publication is from the Lancet Gastroenterology and Hepatology. It's in adults, but I show it to you because I think it's important to know in which direction the research is going. And it was in adults with IBS, irritable bowel syndrome, and this particular HIT inactivated Bifidobacterium bifidum was used here, and it has shown to be beneficial when it comes to symptomatic relief. Here on this slide, I summarize examples of pediatric trials with postbiotics. And again, you can see there were so-called fermented formulas. It's exactly the same concept, just the focus previously was more on the process of the fermentation. And now we are more discussing from the perspective of this postbiotic, of these components which are play important roles. So there is a number of studies looking at some particular effect. Fermented formulas in preterm infants, very limited data, but there are some. There are some with a management of acute gastroenteritis with various inanimated microorganisms. And again, of course, the microorganism plays a role. There are first studies on the prevention of common infectious diseases, limited data on atopic eczema, allergic rhinitis, lactose malabsorption. So definitely, we still need further research as much as we would like to see the paper that ends with the presentation that ends with no further research is needed, but this is not the case. We are not there yet. This is really like an emerging field and a lot is happening. So my summary for this part of my presentation, and I hope I did not went over time, and I know that audience is usually likely to remember only 3 things from each presentation. So here are my 3 things which I think are important. First, that the diversity, that the richness of gut microbiota is an indicator of the microbiota good health. It's better to be rich and healthy than poor and sick. Numerous factors, including antibiotics, which I discuss in more detail, have demonstrated to alter the establishment of the gut microbiota in early life with all these long-term consequences. And as I mentioned, strategies for gut microbiota modification, so-called biotics, are available. Of course, each one of them has to be evaluated separately. A lot is happening, so stay tuned. And I thank you very much for your attention.